Hey guys, welcome to my channel. So basically today we are going to be talking about parabolas. I have an equation in front of me so that we can discuss the equation and things that you can actually get from the equation. Number one, we can see that when a is greater than 0, in other words, when a is positive, then we see a smiley face or happy face. That means the graph will be looking like this, right? However, if a is less than 0, in other words, negative, then you're going to see that the graph is concave down, okay? It's a sad face like that. What about Q? Q, guys, is your y-intercept, which also in grade 10 will also be your turning point. It changes in the higher grades, but in grade 10, you'll see that your y-intercept will also be your turning point, okay? Now, let's just look at this graph here. It says in the diagram, we have the graphs of F, graph of G, and graph of H are shown. And then they say the graph of F that's the x-axis at A, C, and D. Right, so you want to take your highlighter and actually say, okay, where's graph of F? Here's graph of F. You're going to see it cuts, of course, C, D, and F. You also want to take your highlighter and highlight another graph, which in this case would be that. Now they're asking us to calculate the coordinates of A, B, C, and D. They do say that G cuts the y-axis at B. Okay, so we've already seen that actually a graph of G cuts the y-axis at B. Right, so let's start with this equation. So we must determine coordinates A, B, C, and D. Now remember, I have already told you that for every equation, f of x is equal to ax squared plus q. What does this q stand for? We said for the y-intercept, also for the turning point. So if we are given the equation, it means that whatever q is will be our y-intercept. Now, if I were to zoom in here, guys, it's very important to know what is special about each coordinate. For example, if you look at B, what is B? B is the y-intercept because they did say that G cuts the y-axis at B. So that means B is our y-intercept. Also, A is also a y-intercept. What about C and D? What are C and D? C and D are the x-intercept. Guys, if you know what is special about each coordinate, then you will know how to calculate it. I'm also looking at E and F, even though we haven't calculated it, but I can see those are points of intersection. So it'll be very easy for me to actually calculate those points because I know what points are they, right? They are points of intersection, as much as they're named as E and F, but they are points of intersection. Right, so now let's go and calculate what they need us to calculate. Okay. Now, we have an equation of G. It is x squared plus 6. So what is 6? 6 we said is Q, which is the y-intercept. So therefore B would be 0 and 6. Guys, these things you don't have to waste time. I do understand that you know how to find the y-intercept, you let x equal to 0. But in this case, you really don't need to do that because you already know that Q stands for what, right? Also, if we look at A, what is A? A is also the y-intercept. That means if we can find the Q of that equation, right? Remember that we had it highlighted. So let's just go ahead and highlight it. Maybe it will remind you what actually A is and which equation it belongs to. So there we go. We have highlighted. And this is the graph of F. So it's quite easy for us to actually say that, okay, as much as it doesn't look like it's in its standard form, it is in its standard form. It's just that negative x squared usually comes first, and then obviously 4 is positive. So it should look like that for us to read it quite nicely. So therefore we have 0 and 4. Right, so that is our y-intercept now, 0 and 4, because we can see Q is actually 4 in that equation. You see how easy it is, and you are saving time, and that's basically what we expect from you. Now we're looking at C and D. What are those points? Those points are cutting the x-axis, so that means they are x-intercepts. And if they're x-intercepts, we know how to work them out. We say let y equal to 0. So we'll have, now remember guys, you are using the graph of f because the graph of f cuts the x-axis at C and D. So you can't use G, graph of G. You can't also use the graph of H. You can only use the graph of F because that's where it cuts the x-axis at C and D. So we'll have 0 is equal to negative 2x squared plus 4. Now I have 0. Now, here it really depends on how you calculate things, or maybe to make it easier for you. Let's just take the negative x squared to the other side so you can see something. So we'll have x squared minus 4 equal to 0. Now, what do you see? A difference of 2 squares. So now if we factorize it, we'll have x plus 2, and then we'll have x minus 2 equals to 0. So therefore, x is equal to negative 2, or x is equal to positive 2. Now you can just decide from there which one will be which. So C cannot be positive 2, so definitely take the negative 2 and 0. So if, as you can see, x is negative 2, and then y is 0, which makes sense. It's the x-intercept. And D will be positive 2 and 0. Now, maybe we can just talk about the points of intersection. So let's just look at this. What is E and F? As we said, E and F, H and F are actually crossing each other at those points. So basically, points of intersection, this is where h of x is equal to f of x. Right, so what is h of x? H of x is 3x squared. And what is f of x? F of x is 4 minus x squared. All that you need to do is send it to the other side. Now you have 3x squared plus x squared minus 4 equal to 0. Now you have 4x squared minus 4 equal to 0. Now I can decide to take out an HCF, which you know, guys, that you have to take out an HCF first, or look for an HCF before you can actually start factorizing properly. Right, so now I can see that I'll have a 4 and then x plus 1 and then x minus 1 equals 0. So therefore I have x is equal to negative 1 or x is equal to positive 1. Now, I do have those, but these are not x-intercepts. They basically have y values. So we need to now calculate those y values so we can have the coordinates. So we will have, I'll start with when x is equal to negative 1, then we'll have negative 1. I'm just using h of x. You can use f of x as well. So negative 1 all squared. So then the answer will be positive 3. Now that means E is actually negative 1 and 3, which makes sense. I mean, if you look at E, the positive y-axis should have a positive y coordinate, and it should have a negative x coordinate looking at where it is, right? And then if we want to work out f, you guessed it right, we're going to substitute 1. Then we'll have 3, and we substitute 1 there squared, and the answer will just be 3 again. So therefore, f would be, coordinate f will be positive 1 and 3, which makes sense considering where its location is on the Cartesian plane. Right, and that's it, guys. So basically, we have now calculated E, and E is this, and F is the following. Thanks for watching.